In this course, we will be talking about 4 different light sources: tungsten, fluorescent, LED, and HMI. Because this course is lighting basics for video, we're not going to talk about HMI lighting in great detail. The reason for this is because the cheapest HMI lighting system is around $1,500, and that's for a light that has the equivalent output of a 125 watt halogen light. Yes, you heard me correctly. For an HMI lighting system that has some reasonable output, you're looking at something in the range of $5,000 for a single lighting setup. They're just too expensive for most people to own. You can rent them fairly inexpensively, but rental houses are not easily accessible to many people. So for that reason, I will talk about them in this course for reference, but we will not get into HMI usage. It's much more practical to start talking about the lights that are in the price range of most people. So that's what we're going to do. When talking about different lighting instruments, there are 4 attributes that determine how you might use the light: output, color, size, and power requirement. Let's first talk about output. A light's output is the amount of light produced over a given area. The output of a light will determine whether it's going to be useful for your particular application. You're not going to be able to properly light up a large living room space using only 2 LED on-camera lights. They just don't have the punch to cover that much area. Light output is something that is measurable, and many manufacturers will list the light output in the specifications of the light. Let's take a look at this photometric calculator from ARRI for more details. All right, so this is ARRI's lighting page, and they offer a whole bunch of lighting fixtures, and I want to show you here. You can look at these individually. Sometimes they'll have some specifications over here, but they have this tool here called the photometric calculator, and we can launch this and take a look at it. So check this out. We're talking about light output and how it's measured. Well, in the US, we measure it in foot candles. But before we do that, we need to select a fixture. So we're going to pick a tungsten light, and we're going to pick the ARRI light, and we'll pick the 750 plus. Now this is a focus flood kind of open face style. And right now we're seeing a couple of things here. We have the light here with the maximum power. This uses an HPL lamp, and we can set that to our lamp of choice here. By default, it was set on the lowest one, and for the US, we want to pick 115 volts. It doesn't have a lens on it, and because this is a kind of focus flood or spot flood open face type light, we have a couple of options here how we want it to spread. So we're going to change this measurement system here to US, which is measured in foot candles. The distance is feet, and the luminance is measured in foot candles. The metric is meters and lux. It shows us down here that at this flood setting, we have a beam angle of 69 degrees, and this will kind of be the spread of the beam. So we can use these sliders here, slide it around, and get an idea of the kind of output we can expect for this light. This is direct light. It's not bounced. It's not diffused. That's too complicated to calculate because there's just too many variables. You can get an accurate reading with a light meter, but that's probably beyond the scope of this course. But this will give you at least some idea of what you can expect between different light fixtures. So let's say we want to be 10.3 feet, and this gives us an illuminance of 108 foot candles and a beam diameter of 14.2 feet. Now what this means is 10.3 feet away from the thing you're trying to light up, your subject, is going to create a 14.2 diameter circle of light, roughly. It may not be exactly circular depending on the lamp and the fixture, but generally it's going to be some kind of circular type shape. And it's going to give us 108 foot candles. Well, what does that mean exactly for us in our camera system? Well, it also has a camera setup section down here. So we can say if we're using an ISO of about 160 and a shutter angle of, let's say 1/50th, actually for a DSLR, it would actually be 172.8, at least Canon DSLRs, because they don't have a 1/48th second exposure time. And then the camera speed is 24 frames a second. So this is telling us that using these settings, our ISO,
our exposure time, which is 1/50th of a second, which would be normal at 24 frames a second. That's kind of like the natural exposure time look without too little or too much motion blur. We'd need a lens aperture of around 3.68. Now, your lens probably doesn't have something that exact, but it may have something like 3.5, which is pretty close to this. And you could maybe adjust this. So maybe we drop it back 1 foot and now we're at 3.36. So you get kind of an idea, maybe halfway between 10.3 and 11.3, maybe 10.7 or 10.8 would get you exactly the exposure you're going to need for an f-stop of 3.5 or somewhere in that neighborhood at these camera settings. Now you can compare this. We can grab another light here. We can grab a Fresnel. We can get like an RE650 Plus, which is a very popular Fresnel. We can say we want this to be lamped with the 650 watt, 120 volt version of the lamp. Boom, we got it here. So we can slide this back to say 10.2. And at the flood setting, we're getting 104 foot candles. And all our settings here are exactly the same. So you can see, actually, if we slide this back to 11.3, you can see our lens aperture needs to be 3.62. So this light, because of the lensing system, is not giving you exactly the same output as the other 750 open face light, but it's pretty close. It's in the neighborhood, and that's pretty good for a Fresnel. Usually Fresnels are not super efficient of lighting source, but that is pretty good. But then again, ARRI is one of the premier manufacturers of lighting instruments for TV and film, so that would make sense. Now this is just with ARRI. Other manufacturers will have some kind of data. For instance, if you go to etcconnect.com, they're another manufacturer of primarily stage lighting, but you'll find a lot of these fixtures used in TV and cinema, especially the Source 4, which is one of the, I believe it is the king of all spotlights. And they don't really have a photometric calculator, but they do have data sheets for the various fixtures. So if we look at 70-degree version of the Source 4, which means that it has a 70-degree beam field, we can scroll down here and see that we have some data we can work with. So at 10 feet, this particular light at 750 watts is going to give us 223 foot candles, and it's going to make a beam of about 14 feet. Now we can go and compare this to our ARRI light 750, using a 750 on flood, which is a 69-degree beam, and at 10 feet or about there, you can see we get a 108 foot candles and a 14.2 diameter beam. So it just gives you kind of an idea on how to compare these. If you're primarily going to use this light with a chimera or some kind of softbox or as a bounce, it's not nearly as efficient as this Source 4 fixture, which has more than double the output of this light. Now, granted, this fixture is quite a bit larger than this other one, but we'll get into that more later. This just gives you an idea of how some manufacturers will list the output of a light. There's also data here, says to determine illuminations in foot candles at any throw distance, divide the candle power by the distance squared. So they have some data there that you can, really accurately compare. I want this distance and I need this many foot candles. They have the data here that you can kind of compute. Now, all manufacturers may not have all of this data. It just really depends. Most of the kind of larger lighting manufacturers will have some kind of data like this. I know a lot of Lowell fixtures do. They're kind of specialized in smaller travel kind of compact fixtures for guys on the road. ARRI definitely does. ETC has them for all the fixtures that they make. They'll definitely have some specs for you that you can check out.
ARRI offers this tool because they are one of the premier manufacturers of quality lighting instruments for TV and cinema. If you look at lights on eBay or Amazon, they won't have all this data. That doesn't mean they're not useful, it just means that buying them is a little more trial and error, as you really don't know how bright the light is going to be until you get it and put it to use. For tungsten or quartz lights, the output varies between lights, even of the same wattage. This is because the light's construction determines its efficiency. The lensing, the efficiency of the reflector, etc., are all factors that play into how much light output our particular lighting instrument will have. There are many ways to cut the output of a light. For traditional tungsten or quartz lights, they can be dimmed using a dimmer. The more you dim a tungsten light, the lower the color temperature right down to orange. This color shift can be useful, but not always appropriate. You can also use scrims to cut the light output. A scrim is basically like a metal screen that physically blocks the light without drastically affecting the shape or quality. You can also use distance to control output. If you double the distance to a light source, the light will be reduced by 75%. Another way to think about that is, if we want to cut the illumination in half, we need to increase the distance by a factor of 1.4. And to double the illumination, we need to reduce the distance by a factor of 0.7. Nets work just like scrims, but are made of fabric, and vary the amount of light cut depending on the particular net. A diffuser can cut the output of a light, but it also changes the size of the light, which we'll get into more later. You can also dim LEDs and some fluorescents without drastically affecting the color temperature. Fluorescent lights that cannot be dimmed will sometimes have a way to shut off individual bulbs to control the output. You can also use nets, diffusers, and distance to control the output on these lights as well. The output of a particular light is a very important aspect in lighting. Cutting a light's output is a lot easier than adding more light, so having punchy, bright lights can be a real advantage. Let's take a look at color.